Okay, here we are at a soil test pit, and generally what we're doing is we're digging very, very deep soil test pits down to 2 meters, even 2.5 meters, nice wide, and for health and safety reasons we always put in a step at the back, and then as the digger driver is digging, you put the topsoil out in one layer, and the next layer maybe 0.5 meters, then the next layer, and so on, and try to get good feel of the soil. So in terms of sand, silt and clay percentage, we take a sample maybe from the top layer and you play around with it in your hand, make a ball, okay, ball around this size, you roll it in your hand, and then you're pushing the sample out between your thumb and your first finger, okay? So here, for example, I get the sense that there's high clay content in the soil, and if you can push it beyond 2.5 centimeters, that means there's more clay than silt in your soil sample. So here, most definitely we have a clay-dominated soil. Okay, and this is a good exercise. If this was silt, for example, you'd have dust coming off your hands, but this is a very much more clay-dominated soil, polished, and very, very easy to get that 5 centimeters in your finger like that. So you repeat the process for your topsoil, then your next layer and so on, and all the way to the base of your soil profile. This gives you an idea of which layers allow water to pass through and which layers, I suppose, stop water from travelling down the soil profile.
What we're trying to find out is what is the problem in terms of drainage here and drainage capacity, and maybe look at some potential solutions. In this case, the soil is dominated by clays, as well as the texture that Owen has described. We look at structure, so we look at cracking, we look at roots and the movement or the growth of roots, the root pattern down through the soil. We look at the activity close to the surface in terms of potential for water movement, if there's a lot of pore space and cracks for water movement. In this case, we have the clay-dominated soil, and as you get deeper in the profile, the amount of clay is actually increasing. As well as that, we have this platy structure that as we describe it, where you have these layers that appear like stripes and bands in the soil that are stacked on top of each other, and again are slowing down water movement. So in this pit and in other ones like it around the field, it's clear for us to see that there's very slow water movement here, and that a drainage system, if we were at home in Ireland, a drainage system in this soil would be trying to increase the level of cracking close to the surface. So putting in a shallow system, a drain of 90 centimetres to 100 centimetres at 15 to 20 metre spacings, and then on top of that, crisscrossing that with mole drains. So these are shallow unlined channels at 50 to 60 centimetres to create avenues for water to move close to the surface to collect that water and discharge it into the collector drains. Would help the drainage capacity of the soil and mean that there's a lot more days where you don't have water sitting on the surface and the crop is better, thriving better and growing better and producing more for the farmer.
So as Pat said, this is typically a platy structure, which means that its layers being laid down in bands. So the white layer there is a silt-rich layer, okay? And then the next layer down is a clay-rich layer. So this means that water is penetrating, it can penetrate through the platy layer, so it has to go laterally, finding cracks, which then slows the whole water movement in the profile down. So in terms of drainage, this is a very, very poor drained layer. And water is finding it tough to go through it in terms of rainwater. And then in terms of groundwater coming up underneath, that's also been impeded to about 60 centimetres in this soil profile.
We would look at the surface layers and try and distinguish, separate the soil profile into different horizons. So each different horizon is going to be slightly different material and going to behave slightly differently. So again, we're looking at the root mat close to the surface, how far the roots extend, how easy or difficult it is to work these soils or to break these soils apart if there is better structure, it would be easier to manipulate the soils and to break them apart. And as you get deeper through the soil, then you're seeing differences in terms of the how the layers look, in terms of colours and in terms of the materials that are in them and how they behave. And again, you're seeing here this pattern of a series of layers, one on top of the other, that's creating problems in terms of water movement. So for water to move down through this layer, this material, the material itself is high in clay, so very low porosity and very slow water movement. And then where there is lenses of different materials, of silts and different layers in the clay, it's having to navigate through that or laterally across that, and it's not going to make its way down through the soil very easily. And then as you get underneath that layer, you're getting into very sticky, heavy clay-like material, and again dominated by clay. So again, all of this profile is very poor for drainage capacity and very slow for water movement. And it's on the surface, that's going to show itself as water sitting on the surface, shallow roots, and lots of difficulties in sowing a crop and harvesting a crop and getting value out of the field.